Welcome to Wiki Bearings, where we dive into the worlds of engineering excellence, from the automotive marvels to the industrial giants. Join us to explore the wonders that keeps the world in motion. My name is Hassanein Alwan, and I'm your host. So in today's episode, we're going to talk about how to choose the best bearing. What are the main elements that impact the choice of a bearing? Now, there are mainly 8 elements to consider, to think of when choosing a bearing. Of course, the material quality. Now, the inner, the outer, the rolling element, and the cages. Now, if we look at the rolling element, either it's ball or steels. These materials can be made of chrome steel, stainless steel, or ceramic. If we look at the cage, or what we call it the retainer, the cage holds the rolling elements in place, and it's important that it's corrosion and wear resistant. Common material includes steel, brass, polyamide, or phenolic cages. Now, every type of cages have its own advantages and disadvantages. Of course, steel cages, they are durable, especially for high strength. They can withstand high temperature and speed. Steel cages are also suitable for application that requires high load, especially high loads, capacity, and precision. On the other hand, now it's becoming very common for large bearing to use brass cages. Brass cage offers excellent resistance to corrosion. And this is why when we have humidity or some environment, we select to use brass cages. They can handle also high temperature and have a good wear resistance. They are preferred in an application where lubrication contamination is a concern, and this is usually in larger application of bearings. On the other hand, we have polyamide cages. Polyamide cages are also becoming popular options in the recent years because of their lightweight and wear resistant. They have also an exceptional damping for vibration. So for any indoor application or noise-sensitive application, we usually recommend polyamide cages. Another important cage type is what we call phenolic racing cage. Usually constructed from fabric-reinforced phenolic resins, the cage offers excellent dimension stability and can operate under high temperature, and also suitable for high-speed application, anything that above 1,000 RPM or more. Usually this is the choice we go for. However, they are not so durable for heavy loads. So when it comes to heavy loads, steel cages are way better choice. But every type of cage offers its own advantage and disadvantage. And we should look at the application to see how we choose the right cage for our bearings. Now, of course, we covered now the material. So the inner, or we call it the rolling elements, and the cages. Another aspect, or the second important aspect, is precision and tolerance. Bearings are, of course, manufactured with a high precision to ensure uniform dimension and accurate tolerances. This helps in maintaining consistent performance and minimizing the variation operation. Now, if we look, there is 2 main standards. There is the American standard and the ISO standard usually for precision. So we are talking about P6, P4, P5, and so on. And usually in the American application, we are talking about ABIC 5, ABIC 7, ABIC 9, and so on. Now, usually the highest classification in terms of precision in the ISO standard is usually P2 or P4. P4 and P2, what we call them super precision bearings or super precision application. On the American standard, we call them ABIC 9. So ABIC 9 is the top precision on the American classification. So ABIC 9 is considered to be a super precision. In these precision and tolerances, the higher. So when we go with the American classification, of course, ABIC 7 and ABIC 9 is higher precision, but on the ISO classification, P4 and P2 are the super precision or the higher precision. The higher the precision is, the more durable these bearings are, the more speed we can take them, and they usually are lighter in weight. This is when we come up with what we call the precision and the tolerance. Of course, when we select a bearing, we have to think about lubrication. There is no bearing that would function well without a proper lubrication. There is usually 4 aspects that to think about when looking at lubrication. So, of course, what do lubrication do in a bearing? One is to reduce friction and wear. Now, lubrication provides a film between the moving parts. The grease minimizes the direct metal-to-metal contact and reduce the friction between them. And this is why it's also reduce the wear. Another important aspect of lubricants is to cool down the bearings or the application. What we call it heat dissipation. Lubricants helps dissipate heat generating by the friction in the operating elements. And this is why we can call it that it's cooling down the bearings. Now, of course, we should not overdo it. Usually, it's a common mistake that we over-grease bearings or other machinery parts, and that actually can increase the heat and the friction inside the bearing. This is why we should always be aware of the right amount of grease or lubricating we are putting into the machine. Another aspect is to protect against contamination. So grease or lubricants help to seal out dust, water, humidity outside of the bearing, and this is why it's prevented from any damage or reduce the damage. So proper lubrication prevents the contamination from the environment. Now, there is a third or another aspect which is important in terms of choosing the right lubrication, which is corrosion prevention. Many lubricants contain additives that protects against corrosion and oxidation, and this will definitely prolong the bearing life. So these are the most important, the role of lubricating. Of course, there are so many different types of greases or lubricants, but the most common are grease, oil, and solid greases. Now, generally, grease are thickened oil that stays in place to provide a long-lasting lubrication, ideal for application where it's difficult to maintain a consistent supply of oil. So if we have, for example, a gearbox, yes, there is always oil inside that machine, there is no problem. But if we have any machines that we cannot have a normal supply of oil, so we go with greases because they are much more easier to apply, stays in the machine, and they are excellent for long term. They do not need continuous providing or pumping of oil. Now, oil at a higher speed, if we have any high speed application, sometimes we cannot go with grease, so we have to go with oil. Now, oil provides excellent heat dissipation, so they cool the bearings or the machine much better. They are good for minimal resistance, so especially at high speed. Now, when we have a certain application that neither we can use greases or we cannot use oils, now the latest technology is what we call solid lubricants or solid greases. Usually are used in extreme condition where conventional lubrication is not used. That can be at very, very high temperature, vacuum, or sometimes in food application where we do not desire or want any contamination in our food. So solid lubricants becomes the choice. Now, the fourth aspect to consider when choosing a bearing or applying the right bearing is the load capacity. Every bearing is designed for a specific load, and it's very important that we consider what types of loads do we have. Is it an axial load? Is it a radial load? Is it a mix of axial and radial load? These are the aspects to consider. And is it a more dynamic loads or is it more a static load? Because sometimes we overlook some of these aspects and then we have a premature damage of the bearing or bearing failure. Now, when looking at these loads, some bearings are purely designed for radial load, for example, cylindrical roller bearings. Other bearings are purely designed for axial, for example, what we call axial or axial spherical roller bearings or axial bearings. Usually they can only take axial loads. Now, some bearings are very good in taking both axial and radial load, like taper roller bearings. Ball bearings, they are more balanced to take both axial and radial load. Now, when we look at these loads and understand these loads, we will be able to choose the right bearing for that application. Now, many aspects of the loads, sometimes we forget about it or we don't consider it. What is the dominating? Is it the dynamic load or is it a static load? To understand dynamic and static load, just to give an example, if I have a wheel bearing and the car is rolling, this is usually what we call the dynamic load. Now, if I use this car just for storage, so maybe I just fill the car with products and the car is most of the time in static, this is the static load on that bearing. And we have all of these different examples of static loads. Could be a hinge of a door or could be any other application that we do. Most of the time, the static load is dominating that load. So just think about it, static load, the dynamic load, and what types of load we have. Now we come to the fifth aspect. As I said in the beginning, we have 8 different points to consider here when choosing the right bearing. Speed is one of the aspects that we should be very much aware. What are this application and what kind of a speed rating we have? Something that a bearing in a bike that having a speed of 2 RPM, 3 RPM, 20 RPM, 50 RPM. These are types of speed. We go into a car, we have maybe 100 RPM. We go into an airplane where we have thousands of RPM. So where we are using this bearing and the speed rate is a very important aspect and the factor of choosing the right bearing. The maximum speed at which the bearing can operate without causing excessive heat, this is the definition of the speed rate. So usually bearings are rated into different speed rating, and this is also related to the precision and the tolerance of the material. And if we look at in today's, for example, cars or the EV cars, these engines are 10,000 RPM, maybe 20,000 RPM, where the technology have moved to. Where other maybe conventional ICE engines, they have a very different requirement in terms of speed. Now we come up to the 6th aspect of choosing the right bearing and how to choose is the desired durability, the longevity of this bearing. It's very important to think about how long do I need this bearing to operate? Is it a month? Is it a year? Is 2 years? Is 5 years? Because that have a major factor on selecting. Sometimes we have to over-dimension the bearing because we want it to work for a way longer time. If we are putting a bearing on a satellite that's going to the space, I think we should consider a bearing with a way, way longer lifespan. Now, are we putting this in a smaller machine that we can change regularly? Then that requirement becomes very different. Normally, a good bearing should have a long service life and capable of withstand the operational conditions. Now, if we look at the application that we have and how often we do the maintenance and how long life do we expect, that is a factor that have impact on the cost and have impact on all the other aspects when selecting the bearing. So if we are looking at a bearing to change a bearing every 6 months or every 1 year, that requirement on quality and maybe price would be very different than if we need a bearing that's going to work for, 50 years. Of course, this leads us to our 7th parameter, which is the budget, the cost. So cost effective. How can we be more cost effective? How are we cost effective when selecting a bearing? So we want a high quality bearing, but I think in many times we consider these bearings and of course we want the best bearing possible, but then when it's come to the reality of dimension or the engineering, then we have the budget or the cost, which plays a role in selecting a bearing. Now, we have seen how these play a role in sometimes in selecting a bearing and the life out of it. Now, I think we need to have a balance between what I call it performance and cost. And this is the nightmare of the engineers, how to select the best bearing for the best application. And cost plays a role. Now, I've worked with some engineers a few years ago on producing some, for example, air conditions. And we chose the right bearing for the application, and this bearing would last for 5-6 years without any problem. Now, when it's come to the tender and we put the cost together, then we cannot afford to put that bearing. So we have to go back and look at the requirement, how many years are the warranty, what are the expected life of from the consumer perspective. We came back to the board and say, okay, so we cannot afford this bearing, but maybe we can look at other aspect or cheaper application or something that is more cost effective. And then sometime that determines. So we went moving from an air conditions that are guaranteed for 5 years to 3 years warranty instead. And that is only to fit in the budget of the customers. So again, this is a balance that we should think of. Now, do we have the budget? Yes, we can select a better bearing that can last way longer, but the reality is normally different. Now we come to the last aspect, which is the maintenance requirement. Now, when it comes to the bearing or in an automotive application or any application, could be agricultural, we usually have an expectation on how often we can do the maintenance, what is the routine, how easy to do the maintenance, how easy to do the repair. Is this product remotely or this machine remotely located, or is it easy to? That puts a lot of requirement on choosing the right bearing. If you need a bearing that will operate 1 year and we do the maintenance every year, yes, it is one aspect of that. Just to give you an example, a few years ago, we worked with an agricultural farm, we work with a small farming company, and they have their own routine on maintaining and changing the bearings and the seals and all of that before the harvest season. Now, to reduce the possibility of any failure, they would in any way change all the bearings before the harvest season. And then they will run the season without any problem. And before the next season, they would change that again. Now, initially, as an engineer looking for something that's going to work forever, I wanted to work for 5-6 years and so on. I wanted to put the best bearing possible there. But their requirement was different. If they're going to put the bearing that runs for 2 or 3 years, it can happen that during the harvest season or during the season that we have the highest demand, that a breakdown can happen and they cannot afford it. So this is what they decided. Now, if we look at a season or harvesting season, it usually lasts 3, 4, 5 months. So technically, they needed a product that works for these few months, and then they will do the maintenance. So the requirement on the quality of these bearings was not so high. We were able to reduce the cost and expecting a life of 6 months to 1 year, and that's it. And that was their way of maintenance, their way of ensuring their the best result for their machines or for their operation. Now, if we look at other application, maybe these are very remote application or machines that are sitting, could be a wind turbine where the maintenance are very, very difficult and requires a major change, or it's a gearbox sitting in a crane in a port. We don't want to do this every year or every 6 months. We want something that really lasts long, and this is what puts the requirement of the maintenance in a different way. So we want things to last a bit longer. And that, again, minimize the choice or give us the right direction of the choice of the right bearing. Now, sometimes we move from open type bearing to seal type or shielded type just to protect the bearing and to reduce the maintenance. Now, the seals or the shield protect the bearing from any contamination from outside or the moist and so on. So could be sometimes selecting the bearing or some parts or aspects of the bearing so it will last longer and give us the right operation, the right lifespan for our application. Now, this was the 8 most important aspects of selecting a bearing and how to select the best bearing. So if you know these, if you remember them, this is what we need to select the best bearing in the world. Thank you. And that wraps another episode of Wiki Bearings. Don't forget to subscribe for more insight into the fascinating realm of the engineering innovation. Until next time, keep spinning towards greatness.